So for number 13, we're trying to make a matrix of weighted scores and seeing what matrix Mr. Fairy can multiply his 20 by 3 matrix by on the right. Okay, so looking at the problem, we have a 20 by 3 matrix. Normally I would write that out. Let's just kind of imagine this has 20 different rows, but 3 columns is the most important part. So 20 by 3 matrix, right? And this matrix represents all his students and the different scores for each of his exams. So first exam, second exam, and third exam. Okay, let's imagine that there's actually 20 rows, but I can't actually make 20 rows. Okay, so now we have to see what we have to multiply this matrix and what matrix can we actually multiply by. Well, he needs to create a 20 by 1 matrix that contains the weighted scores of each of the students. So we know his end goal is going to be a 20 row by 1 matrix. So his end goal is a 20 by 1 matrix, and he has a 20 by 3 matrix. So we're trying to find out what he is multiplying the 20 by 3 matrix to get this 20 by 1 matrix. And remember, whenever we multiply two matrices, we first have to check the dimensions to see if they qualify so that we can actually multiply them. And remember that we have to have the same inner dimensions as the same number. So that means the amount of columns this matrix has to match how many rows this matrix has. Since this matrix has 3 columns, we know that this matrix right here would have 3 rows because these two have to match. And to figure out how many rows, how many columns this matrix has, we have to look at the outer 2 dimensions, right? Because the outer 2 dimensions will equal the dimensions of the product. So since it would be 20 by blank, and we know it's 20 by 1, we know that this has to be a 3 by 1 matrix because we can actually multiply them since the inner two numbers are the same, and we know the product will be 20 by 1, which it actually is. So that means the matrix that Mr. Fairy has to multiply by is a 3 by 1 matrix.